Yes, hello. Good morning. Um, or afternoon, or evening. Oh no. I'm gonna get right straight back into the same nonsensical distractions that I rambled about last year while making videos and streaming. Anyway, Lauren, you've asked me to go over some of the ways that we factorize. Now, factorizing quadratics is a bit of a strange one to introduce, right? Because we'll sort of introduce it in these courses and in this course especially, we'll go over lots and lots of different ways of doing it. It is something that you will have to be aware of and you'll have to do in later courses. Funny enough, if you went on to do like statistical analysis or any other program that involved a lot of math, frequently this kind of thing will be done by a calculator. It will be done by like a Desmos or a Mathematica or a TI-84 or something. Because unless it's made to work out nice and evenly, it's not going to. But in this course, it is, right? It's all made to work out nice and evenly. The reason I said cautioned you about the um, logic reasoning method is that logic reasoning method is a little bit like saying just look at it and figure it out, right? Forehead. No, that's a that's a Twitch meme. Anyway, no one you wouldn't get anyway. Don't worry about that. It's this little emote. Anyway, but yeah, it kind of means just look at it and figure it out. Now that's being a little bit rude, maybe to the method and the readings. The readings in your book, in your study guide on this method, like I'm showing on the screen above me here, are really good, and you should take a look and read through those. But if you read down through it and you think, well, how in the world do I notice when a number can be split apart like that? Well, that's where decomposition method comes in. And I think decomposition method is kind of just the same thing, just a little bit more regimented in the way that you'll actually move from one step to the next. So for me to say, like I said in the email, that I didn't really want you to focus on logic reasoning, to focus more on the method afterwards. It's a little bit of a false dichotomy because the two methods are very similar and they're interlinked. But I'm just saying that the logic of moving from one small step to the next and breaking it down is, I think, a lot easier to follow in decomposition method. So this example here, I'll work through this with decomposition method, and you'll see how it's basically the same thing, right? So it's not really that it's that much different. This is math 1101A, unit 3. What we're going to be doing here is factorizing. Now, this is a very simple one to get started, and I'm not a huge fan of just doing simple examples because, the book will go on to be a lot more sophisticated ones. But what we do in decomposition method, and I'll do this in a different color. I'll do this in green over here, just to show you. But decomposition method in general, right? We have ax squared plus bx plus c, right? So this is sort of the general way that we will write out a quadratic like this. So what we're going to do for decomposition method is you need to find two numbers that okay. So decomposition method, we have ax squared plus bx plus c, and a, b, and c is how we will order our coefficients, right? These are called the different coefficients. There's one coefficient per term, there's a coefficient in each term, and there's a variable in each term, sort of. There's an x to the power of something, right? Here, there's x to the power of 2, and it isn't the order, which one's first, second, or third, that really matters, although this is normally the way we write them. But the a is the number that's multiplied by the x squared. B is the number that's multiplied by the x, the linear, or the x to the 1. And C is the constant. It's the one that's by itself. We could also imagine it as being multiplied by x to the 0, right? Because x to the 0 is 1, multiplied by 1 doesn't do anything. So we have x to the 2 here, x to the 1 here, and x to the 0 here. Right? But to do decomposition method, we need to find two numbers that multiply to equal a times c, and that add to equal b. Right? So it multiplies to be the same as this number multiplied by that number, and they add to be the same as this number. Now, if that doesn't make sense right away, don't worry about it. It'll make more sense in a second. Here, right, if we take this one, we know that a is equal to 1 because there's no number in front of this x squared. And if there's no number there in multiplication, that means it's a 1, right? Not a 0. So a here is equal to 1. B is equal to -6. It's important to keep the sign. And c is equal to 5. So therefore, we know that a times c is equal to 1 times 5, which is equal to 5. Okay? So what we need is b and a times c. So a times c is 5, b is -6. So now we know we have to find a number. We have to find two numbers that multiply to 5 and add to -6. Okay? So, what numbers do that? Well, what multiplies to 5? So to find that, what we're going to do is we're going to write down the factors of 5. Now, 5 is a prime number. So what are the factors of 5? 1 times 5. Is that it? Are we done now? No, we're not. We're not done because of negatives. -1 times -5 also equals 5. And so now, what we do is we see, well, which of these can add to -6? And obviously these ones. These ones can add to -6. So once we have that, what we're going to do is we're going to rewrite this guy, but we're going to break this middle term down into these two numbers instead. So what we're going to do is we're going to say x squared minus 6x plus 5 equals x squared minus 1x minus 5x plus 5, like so. Okay, so this is the decomposition part. This is where this is where it gets its name. Then what we're going to do is we're going to treat we're going to take these first two terms and we're going to take these second two terms and we're going to treat them like they're in brackets. So this is a step. Okay, I'll like last time, I'll have the convention of writing it out in red if it's a step that we don't always write down. But this is just a step that I'm showing you so that it makes some sense, so that you can see kind of what I'm doing. Now the reason this changed from a minus to a plus is because I've just grouped these together, because this is a minus 5x plus 5. Minus 5x plus 5 is still here, right? Because I kept the minus there. This is an x squared minus 1x. This is an x squared minus 1x. And you'll know from your algebra preparation courses that we did that putting brackets around terms like this doesn't actually affect the terms at all, right? This is the same as that because those two things are the same as -6, and this is the same as that because putting brackets around it doesn't do anything. And again, the reason why this is a plus is because the number out here is a positive 1, because positive 1 is the number that if you multiply something by positive 1, nothing happens. If this was a negative here, that would change both these signs, because if you multiply by -1, something does happen. The signs change. Excuse me. So now that we have these broken down, separated rather, what we're going to do is we're going to find the greatest common factor in this of both terms in this bracket and of both terms in this bracket. So this is very similar to the math that we were just doing in the last video, I believe, or maybe the one before that. So this is one that we would write down now. So here this is an x squared and a -1x. There's an x in both. So I'll factor that x out and put it outside the bracket. Inside now this will become x and this will become minus 1. And over here, I can take out 5 out of both of these. So what I can do now is I can call this plus 5 outside of a negative x plus 1. Now here, this is actually we have one extra step that we don't always have to do here. What we're trying to do, if this can be factorized, and if we've done everything correctly, what we want is for what's in this bracket to be the same as what's in this bracket. But here it's not, right? Because here we have an x minus 1, and here we have a negative x plus 1. But it is mostly the same. It's mostly the same. The only difference is that the signs are switched. You notice this x is positive, this x is negative. This one is negative, this one is positive. So the signs are swapped. So what that means, what we need to do is we need to flip the signs. If we flip both the signs here, then this becomes the same as that. And how do we flip signs? Well, we can divide by minus 1. So we can factor out a negative. So I can call this x outside of x minus 1 minus 5 outside of x minus 1. Right, so what I've done here, if you follow this back, this will totally work out. Because if we do take minus 5 and multiply it by x, we get a negative 5x. If we take minus 5 and multiply it by minus 1, we get a positive 5. Right? And now we have achieved what we wanted to do through this method, which was having this bracket be the same as this bracket. Once we have that, we can now rewrite this because we now have x minus 5 multiplied by x minus 1. And now this is the same as this. This over here. Okay, this might seem like a much more difficult way of doing than it's showing over there, but it's not. Partly because this method allows us to tackle more complicated ones. You can handle simple factorizations using decomposition, and you can handle more difficult ones using it. Logic reasoning frequently gets really hard as the numbers get bigger, but I don't want to say really hard. It gets harder, and very quickly we'll show you to use this one anyway. So, like I said, do go down through this section and look at all these and do the work that's in here, and read down through these sections. Let me know if there's anything that I could explain a bit more. But ultimately, the most versatile way to solve these questions is going to be to use decomposition method. So I'm going to show you another example here now. We'll do one that's a little bit. This is fine. This is fine. I'll do this one. So let's make this a touch smaller to free up some space for myself. So I'll move that one over here. And go ahead and write this out. Now, as always, I will be sending you these notes once I'm done here. So this is number 4 on your logic reasoning section. And again, I'm going to show you how to do this with decomposition. Now, again, it's very, very, very similar. Right, so here we know our A is equal to 8, our B is equal to negative 18, and our C is equal to negative 5. Always important to keep the signs there. So A times C is going to be equal to 8 times negative 5, which is going to be negative 40. And then B is negative 18. So now we need two numbers. to multiply to negative 40 and add to negative 18. So how are we going to do that? Well, first what we need to do is we need to start listing out the different factors of negative 40. So that's going to be 1 times 40. Well, it's negative 1 times 40, or 1 times negative 40. I'll just list them out like this, right? So we have either a negative 2 times 20 or 2 times negative 20. 3 doesn't work. Can't divide 40 by 3. 4 works, so either negative 4 times 10 or 4 times negative 10. Still not there, or are we? Do any of these add to 18? I think we have already gotten there, but I will keep going ahead and writing out more of these. Negative 5 times 8, or 5 times negative 8. 6 doesn't work, 7 doesn't work, 8's already there. That means we're done. Right? If you remember back to factoring, what I recommend you do there is you start with this one, the 1 times the number, and then increase this number by 1 each time, or decrease in this case with negatives, but increase the number by 1 each time, and then see if you can divide the number evenly by that. And then once the number you're trying is equal to one of the numbers that you've written down in your other column, then you know you're done. Right? So 1 times 40 works, 2 times 20 work, 3 doesn't work because 40 divided by 3 is like 13.33333. 4 works, 4 times 10. 5 works, 5 times 8. 6 doesn't work, 7 doesn't work, and now 8 we've already got written down. So once we get to one that we've already got written down, we know we're done. Hold on just a second there. Okay, so we already have now the two numbers that add to negative 18, right? Because we have this one. That's set. Okay, so now we know that 2 and negative 20 are the ones that we're going to use. So what we can do now is we can rewrite 8x squared minus 18x minus 5. That's going to be rewritten as 8x squared plus 2x minus 20x minus 5. Right? And our positive 2 and negative 20 go down in here. Right? Because negative 18 is the same as a positive 2 and a negative 20. So that was totally fine to rewrite that. Now what we're going to do is we're going to find what's the biggest number. What's the common factor, the greatest common factor of both these two? Well, we can divide both those terms by 2x, right? So we can call this 2x outside of 4x plus 1. And what's the biggest number that we can divide both these ones by? Well, that's going to be a negative 5, right? Or the greatest common factor. They're both negative, so I will put a negative on what I take out. And I can divide 20 by 5, and I can divide 5 by 5. So it's going to be minus 5. Outside of 4x plus 1. And now, this has worked. We know that this is working because we have the same thing in both those brackets. We can rewrite this now as 2x minus 5, which is this number outside here and this number outside here. So it's 2x minus 5 multiplied by 4x plus 1. And now we've done it. That is the final answer here. Right? And yeah, that is the way that we will go about doing these ones. Hopefully that makes a bit more sense here now. Like I said, don't ignore the part on logic reasoning. Do read down through it and take a look at the examples. It could be that it makes total sense to you and you want to keep using that method. That's totally fine. Just in my experience, I have found that students often like a method that has very clear steps to proceed through. Even if the method is a little longer sometimes, but having a sort of clear path where we know which step to do when sometimes, you know, is some good scaffolding, right, to help people understand this material. So just to really quickly from the top, what we do, we write down, or we determine which coefficient is A, which is B, which is C, and we find A times C. Then we need two numbers that multiply to give us this thing and add to give us B. So to do that, we start finding all the whole number factors of this number here. And then the way in which you do that is up to you. You can use prime factor decomposition like we were doing earlier in this unit, or you can do this sort of factoring, which is what we did in your refresher courses from 2019 and 2020. Then once you have that, what you're going to do is you're going to go back to your original equation, and you're going to break down the B term to be those two things, which is the next step. Then what you've got to do is you've got to factor, find the greatest common factor of the first two terms and the greatest common factor of the last two terms. And then, as long as what's in this bracket is the same as what's in this bracket, we can rewrite it as the bracket like there, and then these two pieces go together over here. Okay, and then what we have is a fully factored quadratic.